An annuity is a sequence of payments as opposed to just a single one. We could be getting dividend payouts from a stock, coupons on a bond, interest, loan repayments, all of these as a series of payments rather than analyzing each transaction separately and trying to figure out what interest is earned or what. If the payments are regularly spaced, then we can use tricks from geometric series. And a lot of what we're going to do can be made really easy by a spreadsheet, but the formulas themselves have some interesting concepts in them. It can be money coming in, it can be money going out, it depends on the setup, but as long as they are periodic. So they're every week, every month, every 2 weeks, every 6 months, every whatever. Some of them are contingent on circumstances. Life insurance. A life insurance you pay regularly in to a fund. Something happens, you get a cash settlement. But I want to look at what are called annuity certain, which don't have any circumstances to them. You buy 100 shares of stock in company A, and they say every quarter we will pay you 5% of the value of the holdings as a dividend. Regardless of circumstances, that's an annuity certain. I'm just going to say annuity. I'm not going to specify certain versus contingent, but the idea is the important part. So I need a big formula from Calc 2, discrete, whatever series. This is a geometric series. It adds up all the multiples of x, starting with no multiplication, x to the 0, x to the first, second, all the way up to x to the n. Does anybody remember the formula for this thing? It was a long ass time ago. No, just for the finite one. For the infinite one, it's a over 1 minus r. But for the finite one, it turns out to be this. Normally, when we work this out, the order is reversed on the top, and it's x to the 1 minus x to the n minus 1 and 1 minus x on the bottom. I just put the x first. I promise there's a reason for that we're going to see later on. But I want to keep this formula in mind for the first example that we're going to do. Let's think about a deposit into an interest-bearing account. So, 2 questions. How much am I going to put in every how often? And what's the interest rate every how often? All right. The textbook example on page 68 is fairly straightforward. Let's run with that one. When I get paid at the end of the month, I deposit $30 into a savings account. I started doing this May 31st, 2012. I ended December 31st, 2023. The account earns an APR of 9%. How much money do I have January 1st, 2024? I absolutely do not want to figure out the future value of each individual deposit here. Why? Does over 10 years worth, right? How many years, how many deposits do I make? Well, all of 2023, 22, 21, 20, 19, 18, 17, 16, 15, 14, and 13. That's 11 years. And then 8 months out of 2012, May through December. So this is 11 years and 8 months. 11 times 12, 130, that's 140 deposits. So if I worked each and every one of them out by hand, I'd be here forever. But let me see if I can see a pattern in how much money each deposit generates. Remember, I have my timeline idea. Here's December 31st, 2023. Here's May 31st, 2012. But I get paid and I put the money in the bank on the last day. So on December 31st, 2023, I stuck $30 in the bank. I made a deposit right there. 1 month earlier, I made a deposit. A month before that, all the way back to there, right? Okay. The deposit I made in November of 2023 earns interest. It earns 1 month worth of interest. Now, again, I'm going to make a dramatic assumption. I'm going to assume that the interest calculations are monthly, just like my deposits are monthly. If those two things don't agree, I need to have a monthly effective rate. I was given an APR, so I'll convert that to a monthly rate. How much does this $30 earn in interest? When I bring that forward and pick the valuation date of December 31st, how much interest did that amount of money earn? It earned 1 month's worth, right? 1 month at 9%. Wait a minute. That's 0.09 divided by 12, 0.0075. So I would take 1.0075 and multiply by the 30. And that's actually worth an additional 23 cents. But I'm going to write it like this. This is 30 times 1.0075 for 1 month. But that's November's payment. What about October's payment? How much interest will it earn? You don't have to give me a number if you can give me a formula. Because it'll be there for 2 months, it'll get compounded twice. This is October. What about September? December, November, October, September. Okay, wait a minute. What about this one? All the way back in May of 2012. Count carefully. We made 140 deposits, right? But the last one earned 0 interest. So the first one will have earned 139 months instead of 140. Now, really, I made all of these deposits, right? So the total in the bank is 30 plus 31.0075 to the 1 plus 31.0075 squared plus 31.0075 to the 139th. If I factor the 30 out, what's inside that set of parentheses is exactly the geometric series we were looking at earlier. 1 plus x to the first plus x squared plus x cubed plus da 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 da, all the way up to x to the 139th. Hot damn! Because that means I can use that formula. Please notice the number that's on the bottom is just the periodic interest rate, 0.0075. Now I know exactly how much money I have. $1.0075 raised to the 140th power minus 1, close parentheses, divide by 0.0075, take that number, multiply by 30. $7,381, sorry, $85.91. Two questions. First, how much of that was interest? I'm sorry? No. How much of this $7,386 is money the bank gave me? How much of this is interest. Because remember, I put it in the bank, but I only put in $30 each time. You were calculating what you come up with. Because I only put in $30 140 times. So the amount I put in is $4,200. And I made almost that entire amount, 3/4 of it, in interest alone. If instead of doing $30 a month, I did $50 a month, the only thing that would change would be this number out front. As long as my payment is consistent, this formula works perfectly. Questions? This is a level payment annuity. By the way, I did say this formula works all the time. So why not write a program to do it? The calculator already did. Third button down, second column says apps. If I hit apps, the very first application that shows up is labeled finance, which contains a TVM solver. TVM, I've heard that phrase before. What's TVM stand for? This was day one, 2.5 weeks ago. Bingo. The time value of money. I'm going to hit that and look at all these options I suddenly have. I made 140 payments, right? 140 payments at an interest rate of 9%. The present value, the amount I started with nothing, the amount I put in was $30. Why am I making it negative? Because I put it into the account. It went out of my pocket into the account. Payments were made at the end of every month, 12 times a year, and we compounded our interest 12 times a year. If I am floating over this future value button, way down here in green, it says solve. There's a green button right here. I hit alpha, solve. It did exactly the formula we did. One step. Want to change it to $50 a month? Alpha, solve. I love this program. I went in to buy my house with this in my pocket. They were like, well, that's going to be this much. I'm like, really? I only get this. They were not happy. Let's generalize this formula using the notation we already have. If I have a level, let's assume for the moment that my payment is just 1. As long as I know the payment for 1, if I change the dollar value, I can just multiply by that number. And I have an interest rate of I on a per period. So that's like per month, per week, per whatever. And the interest is credited at the same time. So the sneaky thing about the previous example is that I put the money in at the end of every month, and the bank paid interest that night. That's why I knew that that last deposit earned $0. And the one before it earned exactly 1 month's worth of interest because they were happening on the same day. Okay, what's the future value? What's the accumulated value of this? Well, if I'm going to, I need a number of payments. I need to know that. How many payments are we making? Let's say we make n of them. At the end of every period. So the first payment, the first deposit, how many periods of interest does it get? Because it doesn't earn anything until the end of the first month. But that's an interest rate of this per period for that many periods. The second month is going to earn one less month's worth of interest. And so on, all the way to the end. This is exactly the geometric series. I just wrote it in the other order, which means I get x to the n, remember I added 1 to the power, minus 1 over 1 plus I minus 1. X to the n plus 1, well, in this case, it'll be n because we started with 1 fewer. Minus, wait a minute, what happens on the bottom? That formula is given the symbol f, lowercase s, n, a little angle I. It's actually red angle. If the interest rate is clear, we know we're using the same interest rate for a whole bunch of problems, or we've explicitly stated this is the only interest rate we're interested in for this problem, then sometimes they'll just write SN angle and they won't write the I. That bugs the hell out of me. I don't like doing it. I will, as often as I can, put the I in there. I can only do this if the interest rate stays the same the whole time. All the payments are exactly the same. And the payments and the interest are paid at exactly the same time. And the future value is found on the last day. That's why up here, I knew I wasn't going to get any interest between December 31st and January 1st. I said, how much do I have on January 1st? This is called an annuity immediate or an ordinary annuity. Now, the reason I want to name that is because there are other types, but it's a level payment annuity immediate. At the end. The interest is paid the same day as the deposits. So the day when you make the deposit, that deposit hasn't earned interest yet, we go to the next one. Now, clearly, this has a benefit over just sticking money in the bank. Because The fact that I have to put in less each time to build this up, this is a really big exponential growth. Page 71. By the way, here's the formula we're using with SNI. Here's the time diagram that we just drew up. Even at just 10%, this grows quite a lot. Questions? So if I know how much I want in the future at the end of the term of my annuity, I can use this as a savings plan. Again, I'm stealing the dates from the textbook, but we could set this up for however many years moving forward you want. If I start in May of 2018 and end in November of 2025, how many payments every 6 months will I make? But making the payments every 6 months, I'll make them May 1st and November 1st each year, right? So 18, 19, 20, 21, 22, 23, 24, 25. I'll make 8 years worth of payments. That's 16 payments. What is my per period interest rate? Ah, so 4.5%. I don't know how much I'm putting in, but I do know the future value. So really, I just want to solve that. Rather than write out the formula this time, SN 16.045, angle 0.045, I'm just going to write out what it is. So that's 1.045 to the 16th minus 1 over 0.045. Fractions within fractions suck. So let's take the fraction out of the bottom and flip it. That puts the 0.045 on top. Give me a number. By the way, that part's not required. You could work out the term in parentheses first and then do the division. How much do I put away every 6 months? Say again? I'm not sure I got that. There's my top. Divide that by 1.045.
Oh, wait, I put it wrong.
Aha.
But the minus one, but. So I would just.
Makes a difference
Yeah.
because you'll be dividing by a larger number and I'll be dividing by a smaller number. So mine makes, it's really close to 1. 308.11. By the way, again, I can do that in the TVM solver. If I put in the number of payments, the number of conversions per year, I can hit solve here on the payment and it'll generate that same number. 308.11. Is it easier to find $300 every 6 months or 7,000 all at once? So this makes sense, right? I would want to do this sort of thing. So quite frequently, this is the sort of thing that happens to a bond. The bond earns interest, that interest gets deposited into account, it continues to earn interest until we reach a future value decided upon by the face value of the bond. But what if at the end of November of 2025, I decide I'm going to leave this money in the bank for another couple of years and I stop making deposits? What happens then? I decided I didn't need the money in 2025. I could wait until 2028. How do I figure out how much this is worth if I leave the money for another 3 years? We were making all of these regular deposits through to 2025. Right here, each of these deposits was 308.11. Now I keep going. But you'll notice what is missing from that next half of the timeline. There are no more deposits. How do I figure out the value here? There's a simple way and a complicated way. Let's start with the simple way. Money's just sitting in the bank, right? So it's just going to earn interest. How much money was in the bank at this point in time? So all I have to do is take the future value of that 7,000, right? What's the future value of $7,000? $7,000, 1 plus 0.09 over 2 to the 2 times 3. 3 more years is 6 more compounds at 0.45 per period. Give me a number. To the 6th power? I got something substantially bigger than that. Phew. That makes it much different because you're doing it 0.0045. That's a much smaller interest rate. I feel better.
9,100.
Is that what you got to, Adam?
Yeah.
Wonderful. Now that's the easy way to do it. The hard way to do it would be to imagine that we kept making payments. Come. All the way through here. So I made payments the whole time. Well, in that case, the value here would have an extra 6 payments on it. That would be 308.11 times S 22.045. And the value here was 308.11 times S 16.045. But this is the future value of all the payments, right? What about just these payments? How many payments are there? So if I just took those 6 payments, I could take this, subtract this. Here. Now, this looks like a bizarre way to write this, and it's definitely more complicated than this calculation, but something nice happens when I write out what these symbols actually mean. Leave the 30811 out front, and then I get 1.045 to the 22 minus 1 over 0.045 minus 1.045 to the 6 minus 1 over 0.045. If
Why minus S6 instead of minus S 60?
Because the S16 is the money I'm leaving in the bank, and these are the deposits I'm not making, right?
Okay.
So I want to take those extra deposits away. I want to take off the 6 deposits that we didn't make. What happens inside that set of parentheses when I do combining the fractions? Which means 1.045 to the 22 minus 1.045 to the 6. And Maria, now I can see quite clearly, it's the payments all the way to the end, and then take away the payments we didn't make. By the way, there is a slight difference between this answer and the other answer. What do you get for this one? It should be just barely different. The other one was 9115.82. Why am I off by 7 cents? When we did this calculation, this was rounded, wasn't it? So here, this would actually be slightly over because I rounded up by a couple hundredths of a cent or tenths of a cent here. And so this would be like 7,000.01 or 02, and that accumulation carries through. We worked this problem out because we knew we were going to end up with $7,000. But if I was just making payments and didn't know the future value, and then said, oh, I don't need it now, let's leave it for another certain number of years, I can do this same process even without calculating the future value in the middle. So that's the reason for doing this. Page, I forgot what page it is. Example 2.3 in the text does this for a different payment amount. But what that means is I can say, well, wait a minute, I made N deposits, and then I left the money in the bank for K more periods. That means, using this version of the formula, what we did is we did Sn plus Ki minus Sn. I'm sorry, Ki, not N, K. Please notice that there's no payment on this. This assumes the payment is 1, but you could multiply by whatever the payment is. But the other way of doing it was saying, oh, we took the Sni and then brought that forward K periods. I'm going to rearrange this formula just a little. Sn plus Ki equals Sni 1 plus I to the K plus Ki. I use this formula frequently in some of the calculations we do moving forward. You leave money and bring it forward. You stop making deposits. That's fine. This is exactly a useful idea. The reason it's useful has to deal with the fact that in a level annuity, the interest rate stays the same. But in the real world, what happens to interest rates? Right. And if the interest rates change, then I'm going to run into a problem. By the way, this formula that I was just talking about is here. Sn plus K, Sn plus Sk. I put this little arrow in there so I'd be able to find it quickly. If the interest rate changes, then what I could do is I could make subgroups of payments and say all of these payments were made at interest rate 1, and then these payments were made at interest rate 2, these payments were made at interest rate 3, and I can bring them forward in time to match. So, an example. $30 per month from May 1 of 2012 to December 31st of 17 at 9% APR, but from 1/1/18 to December 31, 23, my interest rate went down to 7.5%. All right, wait a second. 2012 to 17, how many payments? This part. Up. It says over there per month. I need the number of months in this section. All of 17, 16, 15, 14, and 13. That's 5 years. That's 60 months. And then in 2012, May, June, July, August, September, October, November, December, that's 8. So this is 68 months. And down here, that's how many? Right, because that's exactly all of 6 years. 18 all the way through the end of 23, that's 72 payments. So let's think about this as two sequences of payments. The first annuity is at 9%. But then that money stays in the bank to here. This is the part that has the regular deposits. This part doesn't. This part is at 9%. This part is at 7.5%. Then this series of payments is at 7.5%. So there are two different calculations we need to do here. We need to calculate the future value of the annuity for the top line and then bring it forward in time. And then we need to calculate the value of the annuity on the bottom line. The one on the bottom line is just one calculation. The other way we could do this is we could say, hey, I'm going to do all the 9% stuff first, and then I'm going to do all the 7.5% stuff. Which way would you like to do the calculation? Line by line or time by time? Time by time. So if I say, okay, we're going to do from 12 to 17, that's $30 a month, future value, 68 payments at what interest rate per month? What I goes here? But that 9% is an APR. That's annual. And I want per month. So, right, that's 0.0075. And now I can figure that number out. Now, if you're being pedantic, you could keep all the decimals. I'm going to round to the penny. But I could do it either way. 30 parentheses, 1.0075 raised to the 68th minus 1, that's the top of the fraction, then divide by 0.0075, that's the bottom. If you really want, you can keep those extra fractions of a penny because technically they do accumulate. Most banks round, and they almost always round down, so they keep those fractions of cents. That's how a bank makes a profit. We'll talk more about that later. So I get 26.4850. And that brings me to this point in time. And now I can think of this as two separate pieces of account. That $2,648.50 sits in the bank and does what? Gains interest. That's all it does. So the accumulated value between 1/1/18 and 12/31/23 is 2648.50 times 1 point. I need a new interest rate. What's my new interest rate? Which is? Because instead of 9, I'm down to 7.5% interest. Oh, how convenient. A nice terminating decimal. And that stays there for 72 months. But at the same time, as this upper line is going on between these two dates, so is this lower line. What is that accumulation? Ta-da! So the money sits in the bank. It earns interest. At the same time, I continue making deposits. And I accumulate an annuity. What's the future value of the deposit that's just sitting there? And if I calculate the value of the second annuity, I get a number for this. Now, I'm a person who will freely admit I'm a pain in the ass and I'm doing all the math. All of this can be done in that finance app. I'd like to see it for the moment. We can use the app to check our work. It's a nice thing to have a technology that just does this really quick. What do you get for this amount? Ta-da! For a total accumulation of 68, 65, 22. If I have more than one rate change, even if it goes up or down, we can do this again by times or by line. By the way, if we'd done it by line, then this multiplication by 0.100625 to the 72nd would have happened up here. That's the only difference. If we'd moved this, bring it forward piece up here to the upper line calculation. Questions? I believe on page 76, 77, there are some time diagrams for this. And I think the textbook does this line by line rather than time by time. So I'm glad we have another piece sitting in front of us. Questions? Talk to me. Okay. What if instead of the rate changing, something else changes? You get a job. You have this job for a finite length of time. Do you make the same salary throughout your entire job? I hope not. So if you were saving for something, you'd be able to save more later. What if your payment changes? I'll leave the interest rate constant this time. You start by making deposits of 50, and then you get a raise, so you decide I'm going to make deposits of 75. The interest rate is still 12%. Let's make these deposits monthly. Maybe you got hired in February and evaluations came out in December. So in January, your salary went up, and that's why you could make more payments at a higher rate after only 10 at the lower amount. What is the total you have at the end of those 24 months? Well, I think of my deposits of 50. They're being made for 10 months. So that's 50 S 10.01, APR of 12%, but I'm making them monthly. But at the end of 10 payments, that money is going to sit in the bank and just earn interest. So I'm going to also multiply by 1.01 to the 14th. And that takes care of the line that is the deposits of 50. And then I started making deposits of 75. And I made 14 of those at 0.01. And that takes me to the end of my payments. I can calculate a value. I'm not going to right at the moment, because there's also another way to think of this. Another way to think of this is I made a $50 deposit for an entire 24 months. But partway through that, I started making another $25 deposit. So instead of thinking of this as 10 deposits of 50 and then 14 deposits of 75, I could instead think of it as 24 deposits of 50 and 14 deposits of 25. This would require me not to bring anything forward, because I could say, oh, in this calculation, that's 50 times S24 0.01, and this is 25, S 14.01. Now, if we calculate, we should get the same number both ways. Which I think is like 1,700 and change. That's the number I have written down. Hopefully that's right. 1722.36. Yes, ma'am.
I'm gonna be able to do the negative numbers, so we give you,
If my payment went down,
yeah,
absolutely.
so you think it was like, we get like 25, you do like.
I could subtract. Yes. And sometimes that's easier rather than stopping, bringing that forward, and then making another one at 40. But that depends on the accountant and the way in which the problem is phrased. When I encounter negatives like that, I almost always end up doing it like this. But that's my preference. Each person is different. You're absolutely welcome to use a negative change in value. It is rare that I know in 5 years I will need exactly $7,000. Let me start saving now. More often and more realistically, I need money right now. I'll pay it back over time. What if instead of looking at this as a future behavior, I look for the present value? Let me think of it this way. I'm setting up a trust fund. This trust fund is going to pay you $1,000 a year from now, 2 years from now, 3 years from now, and 4 years from now. I am going to assume that I can get 6% a year. And I'll make my life easier. We'll just compound annually. Now, this is a very small and relatively simple trust fund. You're going to get $1,000 next year, the year after, and the year after that, and the year after that. 4 years. Most trusts are much more complicated, pay for much longer periods of time, and have much different restrictions on them. I could set this up to give you a monthly payment of, I don't know, $500 for the next 18 years, my child. Okay, how much do I have to put in the bank right now? I'm going to do this in a different method than the textbook does. This example is on page 79, but I don't quite like the way they've written this up. Let's make a timeline. I know I want a future value of 0. Which means here's the money that goes in. Here's the money that comes out and comes out and comes out and comes out. Since I know I want a future value of 0, I can set up an equation of value, picking my time to be the end balance. That's going to be my valuation date. So I'm going to say money in minus all the money out, but let's bring it to this date. Which means I want future values. What is the future value of this $1,000 here when I bring it forward to this date? How much interest will this earn? Nothing. How about this? When I bring it forward to this date, how much will have this earned? No, that's this one. This one doesn't earn anything. How much will have this earned when I bring it forward? What's the time gap from here to here? That's the amount, but let's do it as interest. That'll be 1 year's worth of interest, right? So that's 1.06 to the 1 times 1,000. And it's negative because I'm paying it out. This, how much will that have earned? Ah, 2 years worth. This one, that's negative because it's money going out. What about X? Aha. And that's positive because that's money I put in. And at the end, I want that to be equal to 0. I just hit the clock. So I'm going to stop here, but we're going to pick this problem up on Thursday. Between now and then, I'd like you to do one other thing for me. I'd like to see if you can rearrange that to write it as X equals. But there's something else you need to do for me for Thursday. What's that? You got to bring the homework on Thursday. So on Thursday, chapter 1's homework is due, and we'll pick this up from there. I will see you all then. Have a wonderful rest of your day.